Jackie said that the next programming assignment is about recursion on trees. And he sent me a PDF that contained stuff that you need to know on trees. And I flipped through it quick, and all the definitions of trees we've already covered. There are only two words that he said that I don't think I covered, which was what a path is, right? We might not have defined a path. I added path to our definitions, right? And you know what a path is? It's kind of from the root, you go left, right, you go, and you get to some node. That's a path. And the other word he used that I didn't use is ordered. Some trees, you have a set of children, but there's no particular order to them. And some trees, your children have an order to them, right? So that's that. Otherwise, the things that he had that I didn't have is Java code. So I cut out the Java codes, and I didn't cut. I tried to cut out the Java code, but he didn't cut out. He had some test the code stuff, and I didn't cut that out. But you might be able to, if you can't find his slides, I can get them for you. All right, so we can decide now how much to go over the code, or whether you can just go over the code yourself. The code, it's the same algorithms that I've been presenting. It's just you look at the nuances, I mean, the syntax, right? So we've seen this page already, and the only thing that this page notice is that in software engineering, if you're designing a tree, then you have this big box that's the tree, and a pointer to that big box, and inside of it is the root pointing to a node, which points at a node, right? And when we're writing a recursive program, we want to very quickly, I have a tree, I'm given a tree, and I want to pass a tree to my left tree and my right tree to my subroutines. So you don't want to be pointing at this whole thing. You want to be pointing at a node, right? Does that make sense? So, so here's the he has had a generic tree node 1 and 2, and most of it was the same. So I merged them into one. All right, so you can see he defines a tree node, and the tree node has a parameter E, so it tells you what type the data is. And then it has a parent, which is a tree node, so that's more or less a pointer to your parent. And then it has children. I must admit, I didn't remember this Java notation, but it looks like children is of type array of nodes, right? So you can have as many nodes as you want, though the maximum number of nodes is 10, and number of children, NOC, would be the number we happen to have, right? And then we have tree node. We have a routine called tree node, which is the same name as the name of the object. And so that becomes a constructor, right? If everybody finds what I'm saying obvious, then we'll just go through it. But holler if you're missing something, right? So that tree node is a constructor where you pass it an element of type E, whatever E is. E could be fruit, right? It's a tree of fruit. So you pass it an E, and then you fill in the data for that node. And it's kind of fun that you use this, right? So element is a field of the node, and I'm not sure why I can't just say element, but I I think, right, if you just said element, does that work? Or do you have to say this element? I don't know. You say this element, it means I'm giving a value to myself, my own field, right? And then the children one is kind of interesting, right? Because the variable, the field, I have these great, in my knapsack here, you're going to just be amazed what I have in my knapsack. They went home with me. They went on the floor while I was in Dominican. They came back in my knapsack when I got home, right? So here's a node, and one of its fields is children, right? And what do we want children doing? We want it to be an array of size 10, and then each of these is going to point at another one of these nodes, right? Everybody get the picture? And so when I allocate space for this record, this isn't allocated yet, and this isn't allocated yet, right? So this line here, this line children, right? What is it? You know, I must admit, I can't say I can parse all of this, but, right, it's getting a new array, right? And the class of the array, and somehow it's allocating this thing here, which is an array of 10 nodes, right? So I certainly wouldn't have known all that notation, but better that you learn it than me, right? I mean, really, are you expected to memorize all that for your test? He gives it to you? All right, good, because, you know, I'm not going to memorize all that. Everybody kind of get what we're doing, though? And then we currently have 0 of these nodes. And then here's some other routines, right? If you don't want the world to access these parts, then you hide them and you have external routines to put them in and out of values. To me, it all seems a little silly, but that's because I'm old school, right? Everybody good? Any questions about this page? Then, right now, it's a recursive routine that tells, so what are we passing? We're calculating the depth, right? So the precondition is you give it a node, right? And so it's going to be one of these nodes somewhere deep in your tree, right? So we have a big tree, and there's some node down here, and we're passing in a pointer to this node. And we want to know, there's a unique path from the root down to the node, right? And we want to know how many, well, you know, you have a fence, you can count how many posts there are and how many bars there are, right? So whenever you're talking about depth, you have to know, what's your definition, right? So here it says the root is depth 0. So that means we're probably counting edges, right? So if we have an edge here and an edge here, then this is of depth 0 and 1 and 2, right? Which is the number of edges going up, right? So then what do we say? We say, well, if my parent is null, all right, which node in the tree has a null parent? The root, right? So this guy has a null parent. So it's basically saying, if I'm the root, then the answer is 0, right? Otherwise, what's the answer? Well, I go to my parent. So here's right. I go up to my parent and I say, how deep are you? right? You see we're recursing the depth of I'm in, so in get parent, right? So this is me, in is a little box pointing at this, and in dot parent, so here we have a parent box, and it's pointing up at my parent, right? So in dot parent will be this box, right? And so I give the routine to in dot parent, I give him this, and he says, hey, the depth is 11, right? And then what's my depth? It's going to be 12, right? Everybody get that? All right, so it's, in some ways, it's kind of funny to me that you've already done recursive backtracking to solve problems like the knapsack problem, right? To me, those are pretty complicated. To me, this is pretty easy, right? So in some ways, we're regressing, right? But this is the order we're doing it, right? Everybody good? Oops. Oh, see, I hit the don't work button. Things not to do. There. Oh, okay, here. Oh, here's, oh, this just traces it out a little bit, right? So what's the depth of Vanessa? Well, it's 1 plus the depth of Eliza, right? And what's the depth of Eliza? Well, it's 1 plus the depth of Chris, which is 1 plus the depth of David, and David's depth is 0, right? So we get a depth of 3. Everybody kind of buy this?